So today let's discuss maxima, minima and total differentiation questions of multivariable functions. So before moving on to the previous year questions, let's see the rule that helps us decide whether a point is a maxima point, minima point or a saddle point. So if fx comma y is basically a function, a multivariable function, then we first find out critical points by solving basically partial derivatives of f with respect to x and y and then equating them with 0. So whatever values of x, y we got, that basically gives us the critical points. Then we move on to check d, that is basically fxx into fyy minus fxy whole square. So if it is greater than 0, then a point has extrema or basically the point has extrema at that point. We check it at a comma b point. Suppose if we got a comma b as critical points, then we check basically the sign of d. So if d turns out to be greater than 0 at that point, then the point has extrema at that point. But if d turns out to be less than 0, then d has a saddle point at that point. But if d turns out to be equals to 0, then we cannot comment whether d will be having a extrema or a saddle point at that point. We need to further investigate that function to comment on something. So needs further explanation, further investigation. Now to tell whether the extrema point is basically maxima or minima, we can check either sign of fxx or fyy. If it turns out to be greater than 0, then it is a minima point. And if it turns out to be like any one of them, if it turns out to be less than 0, then it is a maxima point. Now let's move on to the questions and see whether let's solve the questions. So the question 1 says that justify whether 0, 0 is an extrema point for this function. So function fx comma y is basically given to me as 2x raised 4 minus 3x square y plus y square. So I can write it as like this: 2x raised 4 minus 2x square y minus x square y plus y square. And this thing is equals to, if from these two terms I can pull out 2x square. So I'll be left with x square minus y. Likewise, from the remaining two terms, I can pull out a negative of y. So I'll be left with x square minus y. So my function fxy reduces to x square minus y into 2x square minus y. Now we are supposed to check whether the function has basically a extrema point at 0, 0. So for that we'll restore to calculating fx, y minus f0, 0. But if you'll calculate f0, 0, that will be basically 0 only. So this term will be basically equals to x square minus y into 2x square minus y. And if you see that, like, it doesn't have a fixed sign, it depends basically. For example, if let's say this will be greater than 0 whenever this and this both are greater than 0 or both are less than 0. That is, if x square minus y is greater than 0 and 2x square minus y is also greater than 0. That basically gives me x square greater than y and 2x square greater than y. So either this thing holds or x square minus y is less than 0 and 2x square minus y is less than 0. This basically gives me x square less than y and 2x square less than y. Likewise, it can have negative sign also based on the sign of these two factors. if like either one, if one is positive and other one is negative, then it will have a negative sign. So we can say that this thing doesn't have a fixed sign throughout, doesn't have a fixed sign. Throughout, and sign changes depending on values of x comma y. That is, it is greater than 0 if x square is less than y, which is further less than 2x square, and it is less than 0 otherwise. So we can say that like so we can say that 0 comma 0 is basically not a extrema point, is not a extrema point. That is, it neither achieves maximum value nor minimum value. That is neither a maxima or a minima point. This is one way to approach this question. Other method can be, you can just restore to solving, calculating fx equals to 0 and fy equals to 0, and then checking sign of d and then the sign of double derivatives of f. But in this question they have given us that we are supposed to check the nature of point 0 comma 0 only. So this seems a more feasible method to approach this question, because like here you first need to calculate the partial derivatives and then check its point, and then check its sign. So you can restore to this method for these type of questions. So another question says that they have given us a function ux comma y as xy plus 8 by x plus 8 by y, and we are supposed to check the existence of maxima minima of the function. Like we are supposed to first find out the critical points, and then we are supposed to check whether it attains maxima or minima at that point. So let's find out its partial derivative with respect to x. That will be y minus 8 by x square, and uxx will be basically 16 by x cube. Likewise, if I calculate partial derivative with respect to y, it will be x minus 8 by y square, and uyy will be 16 by y cube, and uxy will be basically 1. So for critical points, we need to equate partial derivatives with respect to 0, first order partial derivatives. So that basically gives us y minus 8 by x square equals to 0 and x minus 8 by y squared equals to 0. So if I solve this one for y, I'll be getting y equals to 8 by x square. Now I can use this value of y in this one to solve it for y. So that basically gives me x minus 8 by x square whole square equals to 0. So from here I get x minus x cube by 8 equals to 0. So if I solve it for x, I'll be getting x equals to 0, or x square equals to, here it will be x raised 4, or x cube equals to 8. That is basically x equals to 2. So when my x is 0, so from here if I calculate value of y, then my y is not defined. Y not defined. So from here I cannot say that 0 comma maybe 0 comma infinity is a saddle point. Now let us check at when x is equals to 2, then my y is basically 8 by 4, that is 2 only. So 2 comma 2 is basically a critical point. Now let's restore to finding d, that is basically uxx into uyy minus of uxy square, that is equals to uxx is basically 16 by x cube into 16 by y cube minus uxy 1 square, and at d at 2 comma 2 will be 16 by 8 into 16 by 8 minus 1, that is 4 minus 1 equals to 3, and this thing is greater than 0. So we can say that at 2 comma 2 ux comma y has a extrema point. Now let's check whether it is a maxima or minima. So let's restore to the double derivative of u with respect to x, that is basically 16 by x cube, and at 2 comma 2 it is basically 16 by 8, that is 2, and which is greater than 0. So at 2 comma 2 we can say that the function uxy has minima. Ux comma y attains minima, and minimum value is u at 2 comma 2, that is 2 into 2 plus 8 by 2 plus 8 by 2, that is 4 plus 4 plus 4, that is basically 12. So at 2 comma 2 minimum value is 12. So that completes this question. That's all we are supposed to solve in this question. Let's move on to the next question. So the next question says that use the differentials and find an approximate value of f at 4.1 comma 4.9. So we are supposed to find approximate value of 4.1 comma 4.9, where our fx comma y function is basically defined as x cube plus x square y raised 1 by 2. Now, like in the question, it has explicitly asked us to find it using differentials. So first let us check what will be the value of fx comma y at 4.1 comma 4.9. So that will be basically 4.1 का cube plus 4.9 square into y, that is it is 4.1 square into 9, 4.1 square into 4.9 raise 1 by 2, and that will be basically, you can use calculator to calculate it, that is 4.1 cube it turns out to be 151.29 raised 1 by 2. So this is the value. Now we need to approximate this value using the differential method. So can you observe that this is basically 151.29 under root lies between 12 and 13, like 12 square is basically 144 and 13 square is basically 169. So this value will be somewhere in between 12 to 13. Now we are supposed to find out what that value will be. So let us define another function, capital F of x as capital X under root. Now we'll use this and its derivative to solve it. Let us equate it with the capital Y, where capital Y is basically under root of x. So we are supposed to find value of y that we are supposed to find, and capital X is basically given to us as 151.29. Now I can write this capital X as 144 plus 7.29, right? Now I can assume it as I can write it as capital X plus delta of X. Now I know this, that my capital X is basically 144 and del X is basically 7.29. Now if I calculate partial derivative of y with respect to x, I'll be getting 1 by 2 under root of x. So from here, if I calculate del y, that will be basically dy by dx into del of x. So I can just solve it. Dy by dx is basically 1 upon 2 under root x, and del x is basically 7.29, and we know that we have assumed our capital X to be 144. So del y will be basically 1 by 2 under root 144 into 7.29, and this value will be basically 1 divided by under root of 144 is 12, and 12 times 2 is 24 into 7.29. Now if I solve it, I'll be getting del y as 0.3037. Yeah, they have not specified like till which decimal place we need to find the approximate value, so this much is, I guess, fine. So my del y will be basically equals to f of capital X plus del x minus f of capital X. We know this value as well and this value as well, but we are supposed to find this value. So it is 0.3037 equals to under root 151.29, I guess. Yeah, 151.29 minus capital F of X is basically under root 144. So from here we will get under root 151.29 equals to under root 144 plus 0.3037. So that basically gives me value of under root 151.29 as 12 plus 0.3037, that is 12.3037. So from here I got my value of f 4.1, 4.9 as equals to 12.3037. So this is basically the value of function fxy at point 4.1 and 4.9. So let's see the next question. So in the next question, the examiner asks us to find the maxima and minima for the given function fxy, and we are also supposed to specify if there is any saddle point or not. So let's just first find out the derivatives of f. So fxy is basically equals to x cube plus y cube minus 3x minus 12y plus 20. So fx will be 3x square minus 3 and fxx will be 6x. Likewise fy will be 3y square minus 12 and fyy will be 6y, and fxy will be 0 only. So let's find out critical points first. Critical points. So for that we'll equate partial derivative of f with respect to x and y with 0. So that basically gives me 3x square minus 3 equals to 0 and 3y square minus 12 equals to 0. So from here I got x square equals to 1 and y square equals to 4. So that basically gives me x equals to plus minus 1 and y equals to plus minus 2. So I got basically 4 critical points. So critical points are 1, 2, 1, minus 2, minus 1, 2 and minus 1, minus 2. So we got 4 critical points as this. Now we are supposed to check value of t, that is fxx into fyy minus fxy square. that is basically equals to fxx turns out to be 6x into 6y minus 0 square, that is 36xy. Now let's check its a value based on the critical points that we got. So at 1, 2, d is basically 36 into 1 into 2, that is 72, and it is greater than 0. So it is basically a extrema point. And at 1, minus 2, d is basically 36 into 1 into minus 2, that is minus of 72, which is less than 0. So it's a saddle point. Likewise at minus 1, 2, d is basically 36 into minus 1 into 2, that is negative of 72, which is also less than 0. So it is also a saddle point. And at minus 1 and minus 2, my d is basically 36 into minus 1 into minus 2, that is 72, which is greater than 0. So it is also a point of extrema. Now we are supposed to check at this point, that is 1, 2 and minus 1, minus 2, like whether they are maxima point or a minima point. So 1, 2 and minus 1, minus 2 are extrema points of function fx, y. So let's check sign of fxx at 1, 2. So my fxx is basically 6x, I guess. So it is equals to 6x. So that is basically 6 into 1, which is greater than 0. So at 1, 2, function attains minimum value. Fx, y attains minima. Likewise, we can check value of fxx at minus 1, minus 2, that is 6 into minus 1, which is minus 6, and that is less than 0. So at minus 1, minus 2, fx, y attains maxima. So that's all we are supposed to find out in this question. So in this question there is 1 point of maxima, 1 of minima, and there are 2 saddle points. So let's move on to the next question. So in the next question, find the relative maxima and minima values of the function fx, y. So let's see it. The function fx, y is basically equals to x raised 4 plus y raised 4 minus 2x square plus 4xy minus 2y square. And we are supposed to check its maxima and minima. So let's find out its partial derivatives first. And with respect to x, it will be 4x cube minus 4x plus 4y, and with respect to y, it will be 4y cube plus 4x minus 4y. Likewise, fxx will be 12x square minus 4, and fyy will be 12y square minus 4. Likewise, fxy will be basically 4. Now let's just find out the critical points. So that we'll get by equating first order partial derivative of f with respect to x and y with 0. So if we do so, we'll be getting x cube minus x plus y equals to 0, and y cube plus x minus y equals to 0. Now that basically gives me x cube minus x plus y equals to 0, and from here I'll be getting y cube plus x minus y equals to 0. Now from here I'll be getting x cube equals to x minus y, and from here I'll get y cube equals to negative of x plus y. So that basically gives me x cube equals to negative of y cube. That means x cube plus y cube equals to 0. So if I solve it, I'll be getting x plus y into x square plus y square minus xy equals to 0. So if from here I'll be getting x is equals to minus y, and this will basically give me some imaginary thing. So I can just ignore this factor, and if I substitute x equals to minus y herein, so I'll be getting x cube minus x and y is negative of x equals to 0. That basically gives me x cube minus 2x equals to 0. Now I can take x as common, so that will give me x square minus 2 equals to 0. So from here I got x equals to 0 or x equals to plus minus under root of 2, and y is basically negative of x. So my critical points are either 0, 0 or under root 2, minus root 2 or negative of root 2, root 2. So I got 3 critical points basically. So let's check the sign of d, that is fxx into fyy minus fxy square. That is fxx is basically 12x square minus 4 into 12y square minus 4 minus fxy is 4 square. Now from here I can take 4 common, that is 16 into 3x square minus 1 into 3y square minus 1 minus 1. So at 0, 0, sign of d will be 16 into minus 1 into minus 1 minus 1, that is 0. So we cannot comment using this method at 0, 0, like whether it is extrema point or a saddle point. So we need to investigate it further. So let's check at point under root 2, negative of root 2. So there d will be 16 into 3 into 2 minus 1 and 3 into 2 minus 1 minus 1. So that is basically 16 into 6 minus 1, that is 5 into 6 minus 1, 5 minus 1. 25 minus 1, that is 24. 16 into 24, and that is greater than 0. So it has a extrema point here. Likewise at minus root 2, root 2, d will be 16 into 3 into 2 minus 1 into 3 into 2 minus 1 minus 1. That is 16 into 24. Again, that is also greater than 0. So we have extrema point here as well. Now let's check a sign of fxx, that is 12x square minus 4. 12x square minus 4 at minus root 2 plus root 2, minus root 2, fxx will be basically 12 into 2 minus 4. 12 to the 24 minus 4, this is 20 greater than 0. So here it has minima point. Likewise at negative root 2, root 2, fxx will be again 20, which is also greater than 0. So here also it has point of minima. Now let us investigate whether, let's investigate at point 0, 0. So at 0, 0, my fx, y minus f0, 0 will be basically, it will be x raised 4 plus y raised 4 plus 4xy minus, so it will be x raised 4 plus y raised 4 plus 4xy minus 2x square minus 2y square minus f at 0, 0 will be 0 only. So I can write it as x raised 4 plus y raised 4, and I can take negative of 2 common from this term. So I'll be getting x square plus y square minus 2xy, and this thing will be equals to x raised 4 plus y raised 4 minus 2 into x minus y square. Now you can see that its a sign won't be constant throughout, like it will be greater than 0 whenever x raised 4 plus y raised 4 is greater than 2 times of x minus y whole square, and it will be less than 0 whenever x raised 4 plus y raised 4 is less than 2 times of x minus y square. So we can say that since its sign is not constant throughout, so it is basically a saddle point. It's not a point of extrema. So at 0, 0 fxy doesn't attain extreme values, that is, it's a saddle point. So that's what we're supposed to do. So let's move on to the next question. So the next question says that find maxima and minima in this function, and it's a repeated question. So let's move on to the next question. The next question says that x raised 4 y raised 4, locate the stationary points of the function and determine their nature. This is the question we have done here. So this is also a repeated question. So let's move on to the next question. So the next question says that we have a function f x comma y as x cube plus y cube minus 63x plus y plus 12xy, and we're supposed to find the points of local extrema and saddle points of the function of two variables. So we are supposed to locate its extrema points and the saddle points as well. So let's just first find out the partial derivative. So its first order partial derivative with respect to x will be 3x square minus 63 plus 12y, and partial derivative of second order with respect to x will be 6x. Likewise, first order partial derivative with respect to y will be 3y square minus 63 plus 12x, and partial derivative with respect to y will be 6y, and fxy will be 12. Now let's just find out critical points by equating first order partial derivatives with 0. So if we do so, we'll be getting 3 into x square minus 21 plus 4y equals to 0, and 3 into y square minus 21 plus 4x equals to 0. Now we are supposed to solve it for x and y. So from here I'll be getting x square minus 21 plus 4y equals to 0, and y square minus 21 plus 4x equals to 0. So if I subtract this, let's name it as 1 and 2. So if I subtract 2 from 1, so I'll be getting x square minus y square plus 4 of x minus y equals to 0. So that basically gives me x minus y into x plus y minus 4 into, here it will be 4 of y minus x. So it will be minus 4 of x minus y equals to 0. Now I can take x minus y common throughout, so I'll be getting x plus y minus 4 equals to 0. So that basically gives me either x is equals to y or y is equals to 4 minus x. Now when my x is equals to y, so I can just substitute x equals to y in any of these, that is equation 1 or equation 2. So that basically gives me x square minus 21 plus 4x equals to 0, and it is a quadratic equation in x. So we can easily solve it for x. So that basically gives me x square plus 7x minus 3x minus 21 equals to 0. So it will be, I can pull out x, so it will be x plus 7, and if I pull out negative 3, here also I'll get a factor x plus 7. So it will be x plus 7 into x minus 3. So that basically gives me either x is equals to negative of 7 or x is equals to 3. So from here I got my critical points as minus 7 comma minus 7 and 3 comma 3. Now when my y is equals to 4 minus x, so let's substitute 4 minus x in 1. So that basically gives me x square minus 21 plus 4 of y, that is 4 minus x equals to 0. So if I solve it, I'll be getting x square minus 21 plus 16 minus 4x equals to 0. So from here I'll get x square minus 4x minus of 5 equals to 0. So if I solve it for x, that will give me x square minus 5x plus x minus 5. So from here I will be getting x minus 5 into x plus 1 equals to 0. So that basically gives me x is equals to 5 or x is equals to negative 1. So when my x is equals to 5, my y will be basically 4 minus 5, that is negative of 1. And when my x is equals to negative of 1, my y will be 5. So I got 4 critical points. So critical points are minus 7, 3 comma 3, 5 comma minus 1 and minus 1 comma 5. Now I'm supposed to check its value, like check the sign of d and then determine whether it is a point of extrema or a saddle point. So my d will be basically fxx into fyy minus fxy square, that is my fxx is 6x into 6y minus 12 square. 6x into 6y minus of 12 square, that is basically I can take 12 common or I can take 36 common. So I'll be getting 36 into xy minus 4. Now let's determine sign of d at minus 7 comma minus 7. So d will be 36 into 49 minus 4, that is greater than 0. So it is a extrema point. And at 3 comma 3, my d will be basically 36 into 3, that is 9 minus 4. Again it is greater than 0, so it is also a extrema point. And at 5 comma negative 1, d will be basically equals to 36 into minus 5 minus 4, that is less than 0. So it is a saddle point here. Likewise at minus 1 comma 5, my d will be 36 into minus 5 minus 4, which is also less than 0. So it is a saddle point here as well. Now let's check at minus 7 comma minus 7 and 3 comma 3 whether they are point of maxima or point of minima. So at negative 7 comma negative 7, sign of fxx, that is basically 6x will be minus 6 into 7, that is less than 0. So it is a point of maxima. And at 3 comma 3, my fxx will be basically 6 into 3, that is 18, which is greater than 0. So it is a point of minima. So the function fxy has a minima point at 3 comma 3, a maxima point at negative 7 comma negative 7, and there are two saddle points at 5 comma minus 1 and minus 1 comma 5. So let's move on to the next question. So the next question says that there is a function fx comma y and it asks us to find at what point will fxy have a maxima or minima. So function fx comma y is basically x cube plus 3x square plus y square plus 4xy plus 1. So let's find out its first order partial derivative with respect to x. That will be 3x square plus 6x plus 4y, and its second order partial derivative with respect to x will be 6x plus 6. Likewise, partial derivative of first order with respect to y will be 2y plus 4x, and second order partial derivative with respect to y will be 2, and fxy will be basically 0. No, it will be 4. Yeah, so let's just find out critical points by equating first order partial derivatives with respect to x and y with 0. So that basically gives us 3x square plus 6x plus 4y equals to 0, and 2y plus 4x equals to 0. So if I solve it from here, I'll get y equals to negative of 2x. Now I can substitute this value of y herein to solve it for x. So that basically gives me 3x square plus 6x plus 4 into negative of 2x equals to 0. So from here I'll get 3x square plus 6x minus 8x equals to 0. So from here I'll be getting 3x square minus 2x equals to 0, and I can pull out x from the previous equation. That basically gives me 3x minus 2. So from here I get either x is equals to 0 or x is equals to 2 by 3. So when x is equals to 0, y is also 0, and when x is equals to 2 by 3, y is equals to minus of 4 by 3. So my critical points are 0, 0 and 2 by 3, negative of 4 by 3. So let's check basically sign of d, that is fxx into fyy minus fxy square at these 2 points. So my fxx is basically 6x plus 6 into 2 minus 4 square, and I can take 4 common, so I'll be getting 3x plus 3 minus 4, that is 4 into 3x minus 1. So at 0, 0, d will be basically equals to 4 into negative 1, that is less than 0. So at 0, 0 we have a saddle point. Likewise at 2 by 3, minus 4 by 3, d will be basically 4 into 3 into 2 by 3 minus 1. That is basically 4, which is greater than 0. So it is an extrema point. Now let's find out whether it is maxima or minima. That depends on value of fxx. That is basically 6x plus 6. And at 2 by 3, minus 4 by 3, it will be 6 into 2 by 3 plus 6. That is 6 plus 4, 10, which is greater than 0. So it has a minima point here. So the next question says that show that the function fx, y, z has only one extrema value, and that is basically log of 3 divided by e square. So let's do that. So our function fx, y, fxyz is basically 3 times log of x square plus y square plus z square minus 2 x cube plus y cube plus z cube. So if I take its partial derivative with respect to x, that will be 3 into 2x divided by x square plus y square plus z square minus 6x square, and its partial derivative with respect to y will be, you can see that it is symmetrical basically, so you can write it directly. It will be 6y summation x square minus 6y square, and partial derivative with respect to z will be 6z divided by summation x square minus 6z square. Now for extrema values, like for the points where it attains extrema value, we need to equate these partial derivatives with 0. Fx is equals to 0, Fy is equals to 0, or Fz is equals to 0. Now if I equate this Fx with 0, so I'll be getting 6x. I can take 6x as common, 1 divided by x square plus y square plus z square minus x equals to 0. So that basically gives me either x is equals to 0 or x is equals to 1 divided by x square plus y square plus z square. Likewise, if I'll solve fy equals to 0, then I'll get y equals to 0 or y equals to 1 divided by x square plus y square plus z square. And if I equate fz equals to 0, then I'll get z equals to 0 or z equals to 1 divided by x square plus y square plus z square. So you can see that like at extrema points, like at the points where a function can attain extrema values, x is equals to y is equals to z. So like if I put x is equals to y equals to z in any of these values, so I'll be getting, so one point is basically 0, 0, 0, other will be x equals to 1 divided by x square plus x square plus x square because of this thing. So from here I'll get x into 3x square equals to 1, that basically gives me x cube equals to 1 by 3, and from here I'll get x equals to 1 by 3 raised 1 by 3. And since x is equals to y is equals to z, so my another possible extrema point can be 3 raised 1 by 3 comma 1 divided by 3 raised 1 by 3 comma 1 divided by 3 raised 1 by 3. So we're supposed to check like which one of them is basically a point of extrema. But if you see the question properly, in the question they have defined us that the function fxyz is basically defined for those points where x, y, z are not simultaneously 0. So the function is not defined at 0, 0, 0. So there is no point of checking the possible extrema value at this point. So we'll check at other point only. So if this is basically the point of extrema, so the extrema value will be basically 1 by 3 raised 1 by 3 comma 1 by 3 raised 1 by 3 plus 1 by 3 raised 1 by 3, and it will be 3 into log 1 upon 3 raised 2 by 3 plus 1 upon 3 raised 2 by 3 plus 1 upon 3 raised 2 by 3 minus 2 times x cube, that is 1 by 3 plus 1 by 3 plus 1 by 3, and this thing will be equals to 3 times log of 3 divided by 3 raised 2 by 3 minus 2 times 1, and this will be equals to 3 into log 3 raised 1 by 3 minus 2. This will be equals to log 3 minus 2, and this will be equals to, we know that log of e base e is equals to 1, so I can write it as log 3 minus 2 into 1, and this thing will be equals to log 3 minus 2 into log e, and I can write it as log 3 minus log e square, and we know that log of a divided by is same as log a minus log b. So if I use this formula here, I'll be getting log 3 divided by e square. And in the question also, we are supposed to prove that this is basically the only extreme value possible. Now, like, we haven't checked whether this point is basically a extrema point or not. We just calculated its the function value at this point, and we should check it by by calculating this d, that is fxx into fyy minus fxy square. So like this is in 2 dimension, in 2 variables. In 3 variables we need to check this thing out. So you can do that, or maybe you can leave it like this only, because this is the only point of extrema and it will be achieving this point, achieving the extrema value at this point. So let's move on to see the next question. So in the next question, we are supposed to find the maxima, minima and saddle points of a function z, that is x square minus y square minus x square plus y square divided by 2. So my function z is basically x square minus y square into e raised minus of x square plus y square by 2. So let's just calculate its partial derivative with respect to x. That will be 2x into e raised, for time being, like whenever I'm supposed to write e raised minus x square plus y square by 2, so I'll write it as e raised negative a just to save time, and in the final step I'll just replace this term with this. So it will be e into e raised negative a plus partial derivative of this will be e raised negative a into minus of 2x divided by 2. So I can take e raised negative a as common, so I'll be getting, and here we have x square minus y square as well, so I'll be getting 2x minus of x cube plus xy square. Likewise, partial derivative of second order will be e raised negative a into 2 minus 3x square plus y square plus 2x minus x cube plus xy square into e raised negative a into negative x. And if I take e raised negative a common, so I'll be getting 2 minus 3x square plus y square minus 2x cube minus 2x square plus x raised 4 minus x square y square, and this will be e raised negative of x square plus y square by 2 into 2 minus 5x square plus y square plus x raised 4 minus x square y square. Likewise, partial derivative of z with respect to y will be negative of 2y into e raised minus a plus x square minus y square into e raised minus a into minus y. So I can pull out e raised minus a, that is e raised x square plus y square by 2 into minus 2y minus x square y plus y cube, and its second order partial derivative with respect to y will be e raised negative a into minus 2 minus x square plus 3y square plus minus 2y minus x square y plus y cube into e raised minus a into minus y. So I can pull out e raised minus a, and I'll get minus 2 minus x square plus 3y square plus 2y square plus x square y square minus y raised 4, and this will be equals to e raised minus x square plus y square divided by 2 minus 2 minus x square plus 5y square plus x square y square minus y raised 4. Now I also need zxy, that will be e raised minus a minus of 2xy plus minus 2y minus x square y plus y cube into e raised minus a into minus of x, and I can pull out e raised minus a, that will give you minus 2xy plus 2xy plus x cube y minus xy cube. This term balances this, so we'll get it as e raised negative x square plus y square by 2 into xy can be taken out, and I'll get x square minus y square. So this is basically same as z into xy. Now let's find out the critical points. So for that we need to equate zx with 0 and zy with 0. So my zx is basically, so if you see that this term will never be 0, so this term only basically gives me the critical point, that is 2x minus x cube 2x minus x cube plus xy square equals to 0. Likewise, if I equate zy with 0, I'll be getting minus 2y minus x square y plus y cube equals to 0. So now I need to solve it for x and y. So I can pull out x from here, so I'll get 2 minus x square plus y square equals to 0. And if I pull out negative y from here, so I'll get 2 plus x square minus y square equals to 0. So from here I'll be getting either x is equals to 0 or x square is equals to 2 plus y square. And from here I'll get either y is equals to 0 or 2 plus x square minus y square is equals to 0. So when my x is 0 and I substitute that here, so I'll be getting y equals to 0 or y square is equals to 2. So critical points are either 0, 0 or 0, plus minus root 2. Likewise, when I put x square equals to 2 plus y square here, when x square is equals to 2 plus y square here, so I'll be getting minus y into 2 plus y square minus y square. So this basically gives us only y equals to 0. So if I put y equals to 0 here, so I'll be getting x square equals to 2. So another critical points are plus minus 2, 0. So here we got 5 critical points. So critical points are 0, 0, 0, plus minus root 2 and plus minus root 2, 0. So let's check out nature of D, that is fxx into fyy minus fxy square. So that will be basically, it is zxx. So if I multiply zxx with zyy, so I'll be getting e raised minus x square into the product of remaining term. So it will be e raised minus x square plus y square into 2 minus 5x square plus y square plus x raised 4 minus x square y square plus x raised 4 minus x square y square into minus 2 minus x square plus 5y square minus 2 minus x square plus 5y square plus x square y square minus y raised 4 plus x square y square minus y raised 4 minus square of this term. That will be, we can pull out this thing out and we'll get x square y square into x square minus y square whole square, x square y square into x square minus y square whole square. Now we are supposed to check its sign at these 5 points. So at 0, 0 it will be 2 into minus 2, that is less than 0. So it's a saddle point at 0, 0. Likewise at 0, plus minus root 2. You can see that all the powers of whether x or y, everything is even only. So we can check combined, because plus and negative root 2 will give us the same thing because of the even powers in D. So let's just check its sign. Let's just check these points together only. So we'll be getting e raised minus 2 into 2 minus 2 plus 2, and here it will be negative 2 plus 10 minus 4, and this term will be 0 only. So it will be e raised minus 2 into 4 into 10 minus 6, that is 4. This is 16 e raised negative 2, that is greater than 0. So these points are extrema points. Likewise at plus minus root 2, 0, my D will be e raised minus 2 into 2 minus 10 plus 4 into minus 2 minus 2 and minus 0 square. So this basically gives me e raised minus 2 into 6 minus 10 minus 4 into minus 4, that is again 16 e raised minus 2, which is again greater than 0. So these are also point of extrema. Now let's check which one is a minima point and which one is a maxima point. So my fxx is basically e raised minus x square plus y square by 2 into 2 minus 5x square, 2 minus 5x square plus y square plus x raised 4 minus x square y square. Again at these points, like at 0, plus minus root 2, sign of fxx will be same, because here all the powers of x and y both are even only. So fxx will be at this point e raised minus 2, e raised minus 1 only, and it will be 2 plus 2, that's all. It will be 4 e raised negative 1, which is greater than 0. So here it attains minima value. Likewise fxx at plus minus root 2, 0, so it will be e raised minus 1 into 2 minus 10 plus 4, that is 6 minus 10, that is minus 4 e raised minus 1, which is less than 0. So here the function will attain maxima value. So we got one saddle point, that is 0, 0, and there are two maxima points, that is plus minus root 2, 0, and two minima points, that is 0, plus minus root 2. So let's see another question. So the next question is, they have given us a function fx, y, that is 3x raised 4 minus 7x square y plus 2y square. So this is basically the function that they have given to us, and we are supposed to check the function fx, y for maxima and minima at 0, 0. So we are supposed to check whether it is a maxima point or a minima point. So if you calculate fx, y minus f0, 0, so this thing will be 3x raised 4 plus 2y square minus 7x square y. Now, so if you check in and around the neighborhood points of 0, 0, let's see at at 1, 1. So this term will be basically 3 plus 2 minus 7, that is negative of 2, which is less than 0. But if you check its value at minus 1, 1, so its value will be 3 plus 2 plus 7, that is 12, which is greater than 0. So it doesn't have a fixed sign in and around neighborhood of 0, 0. So we cannot we can conclude that this is neither a point of maxima or a minima. It is basically a saddle point here. So at 0, 0, fx, y doesn't attain extrema values. So it's a saddle point. So this is the last question of this topic. So thank you for watching, and in next video we'll be discussing questions of Lagrange's multiplier method. So thank you.